Okay, you got. And Siddhika, what about you? Did you try this question?
Yes, sir. But I wasn't able to get it either.
Okay, so the important part is that you guys tried and you guys thought about this question. So that is the good idea. Okay, let us discuss this 46th one and then we'll move on to the 45th one. So a body in these type of question, the important thing, as you have also learned in the laws of motion. So in the laws of motion chapter, what was the most important thing? Yes. In your CBSE class, you guys have learned this laws of motion. So in laws of motion, what was the very crucial point? Free body diagrams, right? The pictorial diagrams were very important in laws of motion, right, guys? So similar to that, the pictorial representation is very important in these kind of questions. So first we represent those situation in diagram, and then we try to solve that part. So a body is moving with uniform acceleration, right? So let's say acceleration is right, and it is not written in here that it is starting from rest or what, right? So it has not been given. Am I correct, guys?
Yes, sir.
So what should we do? Let's assume that the initial velocity is u. So what are the two unknowns in this question? What are the two unknowns?
The initial velocity and the acceleration.
Good guys. So now we have two unknowns, which means that we require two linear equations. So to do that, let us write down all the situation. So it describes 40 meters. So this distance is 40 meters, right? So let us write the equation for A to B. Okay. So from A to B, our distance would be how much? And it is the time is 5 seconds, guys. So time is 5 seconds. Yes. So what would be the equation, guys? 40 equals to. You guys tell and I will solve this because in this way you guys will learn, right? So what would be the equation? I'm writing the distance. So second equation, what would be that? 40 equal to?
S equals to ut plus half at square. So
Yeah, so 40, yes, absolutely right, sir. So 40 equals to u, time is given, and then half of A is not given and time is again given. So this I know, right? So this would be 40 plus 5u and then plus 25 by 2a. So I can take 5 common from here. So this would be 5u plus then 5a by 2. And then this is 40. So this 5 cancels this and this is 8. So this is 8 and then this is 2u plus, I have taken the LCM. So let me write it properly and then take it. So u plus 5a by 2. Then I take the LCM, this becomes 2u plus 5a by 2 and then this 2 goes in this side. So 16 equals to 2u plus 5a. So I have gotten the one linear equation that I needed, right? So I've got the first one. Now, using the same initial velocity and acceleration, because we know that the object is moving with uniform acceleration. So throughout this journey from B to C, what is the acceleration? Yes. From B to C, what is the acceleration if acceleration is uniform? Yes, guys. What is the acceleration? Throughout the journey, if something is uniform, that throughout the journey it is same, right?
Yeah.
So if acceleration is this, so acceleration would be again this uniform, right? Throughout the journey, same acceleration. That is what we mean by uniform acceleration, right? Okay. So now the acceleration is this, and 65 meter in next 5 seconds. So this distance is 65 meter, and this distance is 5 seconds, right? So we have to use the same initial velocity, right? So if I am using the same initial velocity, then the journey would be from where to where? If I'm using
A.
the A. So the journey started from A and then to where?
C.
C, right? Absolutely right. Because if I'm writing B to C, then the initial velocity will change. So I have to use some other relation to write the initial velocity. But I don't want to use another variable because I want to use only U and A, only two variables. Okay, so now what is the distance from A to C? Yes, what is the distance, guys?
85 meters.
85. So 65 plus 40,
Not 85. 105.
105, right? So 105, and then this is equal to how much?
UT plus half A square.
Yeah, and time is how much? From A to C.
5
Time
seconds.
A to C, A to C. That is why I have written A to C. So how much is time?
10 seconds.
10 seconds, right? So 10 plus half and A I want to calculate, and 10 into 10. This is 5. This is 105, 10U plus this is what? 58. So I can take 5 common, right, again. So this is 2U plus,
So we can take 10 common, right?
if, yeah, I can take also 10 common, then I cannot divide this by this, right? You're absolutely right. I can take,
Yes, sir.
okay, so want me to take, but that would be decimal, right? 10.5. So that's why I don't want to. Understood, Rishita?
Yes, sir.
So this is 10A. So this is 2 and then 1. So now 21 is 2U plus 10. So you guys, you have two equations and you have to calculate U and A. Please calculate and tell me. So did you guys get these two equations? What equation did you guys get in solving this
Then I
question?
got till the first equation.
You got till the first equation.
Yes, sir.
Then so you reached the
Sir,
half part.
I went wrong. I did the 10 common instead of the 5. I think that's where I went wrong.
Yeah, you did what?
So I took 10 common instead of 5. So because of the decimal, I might have made a mistake.
Yeah, so because of the decimal, it would have been the calculation, but the idea, right? Idea was right. So that is what we have to work on these classes. So if idea is right, then we have to follow the idea. Okay, so you reached right. So only the calculation part was good. Okay, so you guys calculate and tell me what are you getting. Yes, guys, what did you get?
Sir, I'm getting a decimal for initial velocity.
Yes, so the answer is in decimal, right? 2.5, 5.5, 4.7. What did you get?
5.5 meter per second.
So, see, this is the answer, right? And what about you, Siddhika? What did you get?
1 second, sir.
Okay, please. Who got
Sir, could you do the answer, please?
Yeah, okay, so you got stuck.
Yes, sir.
Okay, so good that you told me, right? Okay, so this is two, right? And this is the second, and this is the first equation. So now we have to solve for u and a. So elimination method, right? So the coefficients of u are same. So what should we do? Add or subtract these two equations?
Subtract.
Subtract. So if we subtract these two equations, right, this is minus, minus, minus. So this part getting cancelled, and this is what? 5. and then this is what 5a. So we will get a equal to 1 meter per second square. Right. Now let us put the value in one of the equations. So let's say in this equation. So we have 16 equal to 2u plus 5 into 1, which is 5. So this is 16 minus 5 equal to 2u. So 11 equal to 2u, which means u equal to 5.5 meter per second. Okay. Is this clear?
Yes, sir. Yes, sir.
Okay, so if you guys want to note it down, please note it. Right. And whenever you guys have noted it down, please tell.
Done, sir. We can move on.
Okay, so now just Rishida, you have also noted, right?
Yes, sir.
Now let us do the next question that we will. 45th one. Okay, so this was the question, right? So a car starts from rest and moves with uniform acceleration A on a straight line from 0 to t second, t equals to t second. So let us write this first part, first information. So we have these 2 points, and the car starts from rest. So what is the initial velocity or speed?
0.
Zero. Right? This is 0, and the acceleration is given a, right? And time is also given. Time is t. So this much information is given, right? Now after that, from B to C, okay, from B to C, a constant deceleration brings it to rest. So let's say that the deceleration is, let's say deceleration is A1. And what would be the sign of A1? This is, remember, this is retardation,
Negative.
deceleration, negative. So this is negative. Right. And time, let's say time is, let's say T1. Okay. So now we have this time T1, and in this process, after that, a constant deceleration brings it to rest. So what is the final velocity at this point? What is the final velocity at this point? Yes, a constant deceleration. So let's say it was the speed was increasing at this point A to B. Now we have applied the brakes. So now the speed is decelerating. So and after applying the big brake, it has come to rest. So what is the final velocity, guys? It has come to rest.
0.
Zero, right? So zero. Now we have all these information, and in this process, the average speed of the car. So can you guys recall what was the average speed? What was the average speed? What was the
Total distance by total time.
Yes, absolutely right. So total distance by total time taken. Good. So let's say this distance is S1 and this distance is S2. So we have to calculate S1 plus S2 divided by this time is how much? T, and this time is how much? T1. Correct? Is this correct, guys? Yes, Siddhika and Rishita. This is what
Yes,
we
sir.
Yes.
so this is what we need to calculate. Distance from A to B and distance from B to C. So what would be the distance from A to B? Yes. Yes,
We'll use 80 plus half 80, UT plus
yeah,
half 80.
absolutely, absolutely right. So UT, and remember, let me write it as UT plus half AT square. So U is 0, this part is cancelled, half, acceleration is A, and T is how much? This bigger T, capital T. So T square. So this is our S square. Okay. Now remember to calculate from B to C. We have to calculate S2. And for that, we need UT plus half AT square, right? So to calculate from B to C distance, we have to calculate what is the velocity at this point, right? So we can use from A to B relation, and from A to B relation, what is this velocity? Yes, what is this B velocity at B point from A to B? So from A to B, A is the initial point, B is the final point. So if I'm calculating the speed at B, so what is that? What is that speed from A to B? Yes, guys, from A to B, right? So this is our starting point and this is our final point from A to B. And we have initial velocity. So at this point, what would be the velocity? That would be final velocity, right? So from A to B, right? What would be the final velocity? Can you guys tell me? Yes, yes, Rishita. What is the final velocity?
Zero. Um,
So first equation, first equation. What is the final velocity?
U plus 80.
Right, U plus 80. So U plus 80. Okay, U we know 0, A we know, and T is T. So this is the final velocity or velocity at B. So velocity at this point is 80, right? So if I'm starting my journey from B to C, so this would become my initial velocity. Am I correct or incorrect, guys? Is this correct? So
Yes,
from
sir.
right, so from B to C. Okay, so from B to C, U is 80 and time is t1, right? And then half acceleration is minus a1 and t is t1 square, right? So this is a t t1 minus of half a1 t1 square. Okay, but you guys see that we have lots of, right? So in this S1 we have only A and T, but in S2 we have A, T1, T and lots of T. So what is the other relation that we can use? From B to C, what is the thing that we can use again? I have to simplify this S2. And to do that, I have to find out the value of A1, acceleration A1. So can you guys tell me what would be S2? Or what is the other thing that I can do? From B to C, what is the other information I have written at C point? Yes? Oh, who joined? Learnivio. Okay, so let me tell you guys. So final velocity is 0 at this point. Am I correct, guys? Final velocity is 0. U is a what? T, and acceleration is minus a1. Right. So let us write these scenarios. So V is U plus AT, which is this is 0 and then this is AT and this is minus A1 and time is what? T1. Right. So I will get AT equal to A1 T1. If you guys are confused at any point, so please stop me and say that, please do that part again. So if you guys, yeah, please tell me, did you guys understand this part? Yes, guys.
Yes, sir.
Good. So now let us put this A1 T1 value in this equation. So then what we will get? We'll get S2 equal to AT T1 minus of half and A1 T1 is 8, right? And then this is T. So this is ATT1, this is half ATT1. So 1 minus half is half. So we'll get half ATT1. Is this part clear, guys?
Yes, sir.
Or we could have also used this part also. So B square equal to U square plus 2AS. Uh, so this we can also use in this part. But whatever you guys seem understandable, so use that. Okay, so now we have S2, we have S1, and we have T and T1. So we can calculate the average speed. So this is, let me write it as P average because this would look like, okay. So this is S1 is half AT square, right? And this is half AT T1 divided by T plus T1. So what is common in the numerator, guys? What is common?
A half 80. A
Half
half
80, right?
80.
So half 80. Half, you are correct. Half 80. So half 80 is common and we'll get what? T plus T1. And in the denominator, what do we have? T plus T1. So this guy cancel out and we'll get half 80. So this is our average speed. Okay. So if you guys have any doubt in this question, this would be the answer. If you guys have any doubt in this question, please ask. And yeah, don't keep the doubt within. Understood this question?
Yes, sir.
Yeah. So this question was about calculating the total distance, and we just have to divide it by total time. So this was the question. Please note it down, guys. Siddhika, understood?
Yes, sir.
Okay, so please note it down, guys. I will do two more questions from this uniform acceleration and then we'll do the free fall or motion under gravity. And whenever you guys want me to scroll down the screen, you guys, please,
Done, sir.
done. Rishita, what about you? Oh, who has joined now? Hello, Akib, assalamu alaikum.
Salam, sir.
Yeah, so you are 1 hour late.
So I was there till 3:50 or 3:45. It was saying the host didn't start the meeting.
Oh, okay. Yeah, so okay, yeah. So I started yeah, uh, 40 hours, 40 minutes before. So I started 40 minutes. Okay, so did you do that problem that I gave in the previous class? Did you try that question?
Sir, half done. I didn't got other.
Half done and okay. So where did you get stuck? Did you get the both? Did you get those two equations?
Sir, like only one.
One equation. What did you get?
And that is also wrong, maybe.
So don't.
So I cancelled it and doing again.
Yeah. So have confidence in your calculation, right? Whatever it's
Yes, sir.
wrong or right, have confidence in your calculation.
Yes, sir.
Okay. So yeah. So we did this problem. And Rishita, did you noted it down?
Yes, sir.
Okay, so we were doing this problem, right, in the previous class, Akif. So the journey was in the two parts. In first part A to B, there was acceleration. So the car reached a maximum value, maximum velocity, and then after this point, the car started to decelerate or retard. Then it stopped at some point after some time t. So the question was that from A to C, we have to calculate the average speed. So to do that, we have to calculate, Rishida, as Rishida pointed out, we have to calculate total distance by total time. So from A to B, the distance is S1 and B to C distance is S2. So we calculated S1 and S2 and then we divided it by total time. So this was the equation. You please take the screenshot of this question and then we do the next one. Okay. Try to understand and then if you face any problem, then please ask.
Yes, sir. Finish. Sir.
Okay, and this part also done.
Yes, sir.
Okay, so now we will do some portion of maths, which is needed in the uh, with minimum. Okay, so 48 question. This 47th question is so it has some mistake. We'll not do that, but 48 question. Okay, so but before we do that, let me talk about some concepts first. So we have a function. So this is called maximum or minimum value of a function. Okay. So you guys will see that why calculus is so vast and how is that used. So let's say that you have a function which is going like right, so not like this, but let's say this is some function. So if I ask you guys that how many minimum and maximum values are there for this function? So can you guys tell how many minimum and maximum values are there?
Sir, minimum two,
Minimum 2 and maximum.
3.
So let's say that, yeah, this is not going down, right? So let's say that, yeah, only one maximum value, okay? And as you say, two minimum value, right? Because if I am here and I will look in both the sides, so both sides will have higher values. This is me, right? And then this is also minimum value and this point is maximum value, right?
Yes,
So
sir.
because in this part, whenever the curve is changing, so in here the curve is decreasing, right? But at this point, from this point, the curve started to increase. So the behavior of this curve or this function, right? This is fx and this is x. So behavior of fx is changing at this point, and this point, right? So at these
Yes,
two
sir.
points, yeah, at these 2 points, so this is the minimum and this is the max. Okay, so this is the pictorial representation of maximum or minimum value of a function. So you have a function like this, right? And if we want to know the maximum and minimum value, so we have to figure out where the curve is changing the behavior, where the function is changing the behavior. So from here, here, and here we can see, and this is the maximum value, and these are the two minimum values. Okay.
Yes, sir.
Okay. Similarly, let's say that we have this figure, right? So this function has a minima. Is this function has a minima?
No, sir.
No, right? Because this function has only a maxima at this point. Right? It doesn't contain because the curve is changing or the function is changing its behavior only at this point. Right? It was increasing and then at this point it is so it started decreasing. So that is why it has only a maximum or maximum point. Okay. So how mathematically we can calculate the point where the maxima or minima will occur, right? So how do we do that? So let's say we have a function y which is 3x squared plus 4x plus 3. So this is a function, right? And if I want to know that at what value of x, so it has, right, it has x and it has y. So this is the point where the maximum value occurs. And this is the maximum value, right? This is
Yes,
point.
sir.
So there are two parts of this equation. One is that where the maximum or minimum value occurring. Okay, so that is x point, and second is that what is the maximum value? What is the maximum value? Okay, so this is y value, right? The value of the function at that point. So let's say that this is x1. So if I calculate f of x1, right, the value of the function at x1. So that will give me the maximum or minimum value. Is this point clear, guys?
Yes, sir.
So how do we calculate that? So these are called the critical points. Okay, so critical points. So how do we calculate the critical point? So to calculate the critical point, we differentiate the function. So we differentiate the function and put it equal to 0. Right. So this is how we get the critical points. Is this part clear?
Yes, sir.
So you guys, I have this y function and you guys calculate what is dy by dx. Okay. And put it equal to 0 and find the value of x. these are the things that you guys have to calculate. To be precise, you have to calculate the critical points. So calculate the critical point for this equation. Yes, you guys understand the problem.
Trying, sir.
Please calculate because you guys already know the differentiation, right? Yes, guys.
Not getting, sir.
And Rishita and Sika, what about you guys? You guys just have to differentiate this one. Yes, Rishita and Siddhika, what about you guys?
Sir, I'm still doing it.
Let me do that and you guys check. So we have y is and question is find the critical.
Sir, I got 3x plus 4 for the differentiation.
Oh, good. So 3x plus 4 or 6x plus 4? Hmm. What would be the differentiation? So y is 3x square,
6x, 6x.
right? So dy by dx is 6x plus 4. I'm directly doing it, right? So you are differentiating d by dx of 3x square and 4x plus 3. So you guys have practiced this part, so this would be 6x plus 4. Now this is dy by dx. And to calculate the critical point, what do? You put dy by dx equal to 0, which means that 6x plus 4 equal to 0. So which is 6x equal to minus 4, so x is minus 4 by 6. So this is 2 by 3. So x is minus 2 by 3. So you have, right, you have a function, and at x equal to minus 2 by 3, you will get something like this one, maxima, or I guess it can be minima or maxima. You don't know yet, right? So I will not talk about that what kind of point it will be. It can be either maximum or minimum point, right? Because we have to differentiate it further to know about the maximum or minimum point. But we'll not talk about that. We only want to calculate the critical point. So this is the critical point. Did you guys understand this part?
Yes, sir.
And if this is the x value, so if we calculate y value at minus 2 by 3, so this would be what? This is 3 and minus 2 by 3 plus 4 into minus 2 by 3 and plus 3. So this is how much? 3 into 4 by 9 plus or minus, so minus 8 by 3 plus 3. So this is 4 by 3 minus 8 by 3. So this is how much? Minus 4 by 3 plus 3. So this is minus 4 plus 9 by 3. So this is 5 by 3. Okay. So this is the maximum or minimum value, right? And you guys can see that we only have the positive values. So this would be the minimum values. Okay. So this is the y, which is maximum or minimum value. But actually it is a minimum value. So this part we don't need to. Okay. So is this part clear, guys?
Yes, sir.
Yeah. And Rishita and Siddhika, what about you guys?
Yes, sir.
Okay, so if you guys want me to explain it again, I can explain, but if you guys understood, then it is. So please note it down from here. Because whenever you guys will see maximum or minimum question, so ultimately you guys have to do a differentiation, right? And put it to equal to 0, and then we'll get the critical points. And at that critical point, we'll get the maximum or minimum value. Okay.
Yes, sir.
So please quickly note it down, and then we'll do the next question, which is based on this problem.
Finish, sir.
Yes, whenever you guys have noted it down, please
Finish, sir.
then please this one actually. Yeah.
Finish, sir.
So this is the maximum or minimum value, and this is the where the maximum and minimum values are occurring. So this is critical points or critical point, and this is the maximum or minimum value at that critical point. Noted, Rishita, Sutika, and Akif.
Yes, sir.
Yes, sir.
Okay, so now you guys know the minimum or maximum value. So now this is a question. Okay, so a man is, so this is a man, and it is 44, 5 meter behind, and this is a bus. Okay, so when the bus starts accelerating from rest, so the velocity or the speed of bus is zero, and it accelerated from 2.5 meter per second square. Right. With what minimum velocity should the man starts running to catch the bus? So the man is running with some velocity, right? And remember, the man is not accelerating. So if the man is not accelerating, only the bus is accelerating. So we have to find out what minimum velocity, right? So you are seeing that this is minimum. So what should we calculate? If it is saying
Distance.
so minimum velocity, right? So we have to calculate the critical points, right?
Yes, sir.
Okay. So first, yeah, you are saying that to catch the bus, we have to calculate the distance. So let's say that this is at this point the man catch the bus, right? At this point. So let's say that the man starts with u velocity, right? And at t time, it reaches this meeting point. So what should we call it? Catching point, right? Let's say C. Okay. So catching point. Now, what is the distance that man has covered from M to C?
Sorry, sir.
What is the distance man has covered from M to C?
T.
Distance, time is T. Speed is U, the time is T. So what is the, yes, what is the, uh, what is the distance from M to C?
Sir, can we write the distance between B to C as?
Yeah, we can write that, but first we have to write the man part. So the man covered this much distance. To catch the bus at this point, man covered this much distance, right? So what is the distance of from M to C, right? What is the distance? UT, right? Speed is U, time is T, and acceleration is 0. So only UT, right?
Yes, sir.
Now, how much bus has traveled from B to C? How much bus has traveled?
Half 80 square.
Yes, absolutely right. So half, which is let's say BC, this is UT plus half AT square. So this is 0, so only half, and this is 2.5. So 2.5 by 2t square. Correct, guys? Is this correct?
Yes, sir.
So now to catch the bus, the man has traveled MC, right? And it has to be equal to the distance from the man to bus plus how much the bus has covered. Is this part clear?
Yes, sir.
So MC is how much? This is UT, and MB is 45, and BC is 2.5. Let's say this is 20. So this is 5 by 5 by 4 t square. Understood, guys?
Yes,
So
sir.
this is your U equal to 45 by t plus 5 by 4 t square. Now by t. So this t cancel and you have 45 by t plus 5 by 4 t. So now you have this y, which is function of x. So now you have to find out minimum u value. So what you have to find out? What you need to find out, guys?
Time
Yeah,
and then minimum velocity.
yeah. So we have to find the critical point, critical time, right?
Yes, sir.
So you have this equation, and you guys please find the critical time. So you guys understood the problem, right?
Yes, sir.
Rishida and Siddhika,
Yes,
what
sir.
about? Okay, so please find the critical point. Yes, guys, what did you get?
Solving, sir.
Okay, so in the chat box, not getting. Okay, Rishita and Siddhika, what about you guys? You have to find the critical point. So we have to just find du by dt. This is d by dt of 45 by t plus 5 by 4t. Right, so this is 45 is outside and d by dt of 1 by t. Right, so 1 by t is how much? 1 by t is t to the power minus 1. And then 5 by 4 dt by dt. So this is 1. So you have 45 t minus 1 is here and then t minus 2 plus 5 by 4. So this is minus 45 by t square plus 5 by 4 and this is equal to 0. So this is how much? This is 45 by t square and this is equal to 5 by 4. This is 9, right? So t square is 36, so t is plus minus 6. Time can be negative, right?
No, sir.
So t is 6. Now we have got the critical point. T is 6. So now we have to calculate what is the minimum value or maximum. So in this case, this would be minimum. So putting t equal to 6 in this equation. So u would be 45 by 6 plus 5 by 4 into 6. So this is how much? This and this is okay. So both are 15 by 2. So 2 into 15 by 2, which is 15 meter per second. So this one, C. Did you guys get the question?
Yes, sir.
So this is the minimum speed, right, with which the man has to start to catch the bus at this point. So you guys please note it down and then yes, please note it down and tell. And if you guys have any doubt, so please ask.
Done, sir.
Done. Rishita and Aki, what about you guys?
Yes, sir.
Okay, then also please note down.
So please can you explain this U part, the last one?
Okay, so when we differentiate and put it equal
No,
to
no, sir, the left one. U is equal to 45 by 6.
yeah, so we have got the critical point. We've got the value of x where we get the minimum value, right?
Yes, sir.
So this is our x value. And if I put this x in the function is this, right?
Yes, sir.
Yeah, this is y equal to fx. And x is 6. So when I calculate f at 6, so this would give me what? Minimum value, right? So
Yes, sir.
that is this one. Okay, noted everybody? Good, that you asked that. So whenever you guys have doubt, please ask.